June 2019, further pure math sequences. Number 10. Two sequences un and vn for n belonging to the set of natural numbers are defined as follows. This sequence and this one are called recursive or inductively defined sequences. Any sequence un is said to be recursive if u0 equals to any constant, say a, and un plus 1 is equals to a function of un, or un plus 1 is equals to a function of un and another sequence vn. Roman 1, let's calculate u1, v1, u2, and v2. You know, un plus 1 is equals to half into un plus vn. N was in the set of natural numbers. That is, n can be 0, 1, 2, and so on. Now, let's choose n to be equals to 0. u0 plus 1 is equals to half into u0 plus v0. That's we substitute n equals to 0 anywhere we see n here. That is, u1 is equals to half into u0 plus v0. But from the question, u0 equals to 3, v0 equals to 4. That is, u1 is equals to half into 3 plus 4, which is equals to 7 on 2. v1. From the question, we know vn plus 1 is equals to half into un plus 1 plus vn. To calculate v1, we choose n to be equals to 0. That is, v0 plus 1 is equals to half into u0 plus 1 plus v0. That is, v1 is equals to half into u1 plus v0. That is, v1 is equals to half into 7 over 2 since u1 is 7 over 2 plus 4 since v0 is equals to 4. That's v1 is equals to half into 2 times 4 is 8, 8 plus 7 is 15, 15 over 2. 1 times 15 is 15, 2 times 2 is 4, which is equals to 15 over 4. To calculate u2, we need to set n equals to 1. That is, from this formula, u1 plus 1 is equals to half into u1 plus v1, which is equals to half into 7 on 2 plus 15 on 4. Since u1 was 7 on 2, v1 is 15 on 4, which equals to half into 29 on 4. u2 is equals to 1 times 29 is 29, 2 times 4 is 8, 29 over 8. To calculate v2, we need to set n equals to 1. From this formula, v1 plus 1 is equals to half into u1 plus 1 plus v1, which is equals to half into u2 plus v1, which is equals to half into 29 over 8 plus 15 over 4. Since u2 is 29 over 8 and v1 was 15 over 4, that is half into 59 over 8, giving v2 to be equals to 59 over 16. Roman 2. Show that Wn is a convergent geometric sequence. To show that any sequence Tn is a geometric sequence, we are required to show that Tn plus 1 all over Tn is equal to a constant r. And for the geometric sequence to be convergent, Mach r must be less than 1. Now, to show that Wn is a convergent geometric sequence, we are required to prove that Wn plus 1 over Wn is equals to r, where Mach r is less than 1. Wn is equals to Vn minus Un. From the equation, Wn plus 1 is equals to Vn plus 1 minus Un plus 1. That's substituting Un plus 1 in the place of n. Is equals to half into Un plus 1 plus Vn, which is Vn plus 1 from the equation, minus half into Un plus Vn, which is Un plus 1 from the equation. Factorizing half outside, I'll have Un plus 1 minus Un plus Vn minus Vn. That's Wn plus 1 is equals to half into Un plus 1 minus Un. Since Vn minus Vn is 0, is equals to half into Un plus Vn from here, minus Un is equals to half into Un over 2 plus Vn over 2 minus Un. Let's say the LCM here is 2. 2a1, 2 times Un is Un plus Vn. 1 into 2 is 2. 2 times Un minus 2Un. That's not forgetting this half outside. That means Wn plus 1 is equals to 1 and 2 times 1 and 2 into Vn minus Un. Since Un minus 2Un is minus Un, which is equals to 1/4 into Vn minus Un, since half times half is 1/4. Now, Wn plus 1 over Wn is equals to 1/4 into Vn minus Un over Vn minus Un from the equation. Vn minus Un cancels here, and we're left with 1/4. Since Wn plus 1 over Wn is equals to 1/4, which is a constant, therefore the sequence W is a geometric sequence as required. We have also seen that r is equals to 1/4. Mach r is equals to 1/4, which is less than 1. Therefore, Wn is a convergent geometric sequence. Express Wn as a function of n and obtain its limit. You know, the general term of any geometric sequence, un, is equal to u0 r to the n, where n belongs to the set of natural numbers. That is, n is equals to 0, 1, 2, and so on. Or un is equals to u1 r to the n minus 1, where n belongs to the set of natural numbers, star. That is, n is equals to 1, 2, 3, and so on. From Roman 2, we know that Wn is a geometric sequence. That is, Wn can be given by W0 R to the n, where n belongs to the set of natural numbers. That's n starting from 0 and above. But we know Wn is equals to Vn minus Un. That means W0 is equals to V0 minus U0. But we know U0 equals 3 and V0 equals to 4. That is 4 minus 3, which is equals to 1. From Roman 2, R was equals to 1/4. That means Wn is equals to 1 into 1/4 to the power n. That is, Wn is equals to 1/4 to the power n, where n belongs to the set of natural numbers. So we have expressed Wn in terms of n as required. We also need to obtain the limit of Wn. The limit of any sequence is the value of lim un as n becomes very large. That means lim Wn as n becomes very large is equals to lim 1/4 to the n as n turns to infinity. That is, lim Wn as n turns to infinity is equals to lim 1/4 to the n, sim 1 to the n is 1 as n turns to infinity, which is equals to 1/4 to the infinity, which is equals to 0. Roman 4. Study the sense of variation or monotony of Un and Vn. To study the sense of variation of a sequence or monotony of the sequence is to find out whether the sequence is increasing, decreasing, or constant. We know Un plus 1 is equals to half into Un plus Vn. Here we need to find out whether Un plus 1 is less than or equals to Un for a decreasing sequence. Un plus 1 is greater than or equals to Un for an increasing sequence. Un plus 1 is equals to Un for a constant sequence. We know U0 is equals to 3. You know when n is equals to 0, U1 is equals to 7 on 2, as we got from Roman 1. And when n is equals to 1, that's 1 plus 1, we got U2 is equals to 29/8. From all these cases, we discovered 3 is less than or equals to 7/2. 7/2 is less than or equals to 29/8. That means U0 is less than or equals to U1, and U1 is less than or equals to U2. From here, we can conclude that U2 will be less than or equals to U3, and U3 will be less than or equals to U4, and so on up to Un. That means Un plus 1 is greater than or equals to Un. Therefore, Un is an increasing sequence. We know Vn plus 1 is equals to half into Un plus 1 plus Vn. And V0 equals to 4 from the question. V1 is equals to 15/4 from Roman 1. V2 is equals to 59/16 from Roman 1. From here, we can observe that 4 is greater than or equals to 15/4, and 15/4 is greater than or equals to 59/16. That means V0 is greater than or equals to V1, greater than or equals to V2, and V2 will be greater than or equals to V3, greater than or equals to V4, and so on up to Vn. It's the same like V1 is less than V0, V2 is less than V1, V3 is less than V2. Therefore, Vn plus 1 will be less than Vn. Therefore, Vn is a decreasing sequence. To show that Tn is a constant sequence is to show that Tn plus 1 is equals to Tn. That is, Tn plus 1 minus Tn is equals to 0. Tn is equals to Un plus 2Vn over 3. Un plus 1 plus 2Vn plus 1 over 3 is equals to 1 on 3 into half Un plus Vn plus 2 times half into Un plus 1 plus Vn. Un plus 1 and Vn plus 1 are gotten from the question. 1 on 3 into half Un plus half Vn. That's multiplying the bracket out. Plus Un plus 1 plus Vn, since 2 cancels 2. That is 1/3 into half Un plus 3 over 2 Vn, since half Vn plus Vn is 3 over 2 Vn. Plus Un plus 1, that's 1/3 into half Un plus 3 over 2 Vn plus half into Un plus Vn is equals to 1/3 into half Un 3 over 2 Vn plus half Un plus half Vn. Half Un plus half Un is equals to 1/3 into Un, since half Un plus half Un is Un, plus 2 Vn, since 3 over 2 Vn plus 1 over 2 Vn is the same like 3 plus 1, that's 4 Vn all over 2, which is 2 Vn, which is the same like 1/3 into Un plus 2 Vn. That means Tn plus 1 minus Tn is equals to 1/3 into Un plus 2Vn minus Tn, which is Un plus 2Vn over 3, which is the same like 1/3 into Un plus 2Vn, which is equals to 0 as required. Number 6, hence obtain the limits of the sequence Un and Vn. Hence means we should obtain the limits using the idea in Roman 5. You know, Un is a recursive sequence. Then lim Un plus 1 as n turns to infinity is equals to lim Un as n turns to infinity. This idea is same for all recursive sequences. Also, since Vn is a recursive sequence, it means lim Vn plus 1 as n turns to infinity is equals to lim Vn as n turns to infinity. Let us say this limit of Un was equals to U, and let's say the limit of Vn was equals to a constant V. But we know Un plus 1 is equals to half half un plus vn. It means lim un plus 1 as n turns to infinity is equals to lim half of un plus vn as n turns to infinity. Lim un plus 1 is u as n turns to infinity. That is, u is equals to half into u plus v. Since lim un as n turns to infinity is u and lim vn as n turns to infinity is v, that is, u is equals to half u plus half v. U minus half u is half u. That's equals to half v, meaning u is equals to v. That means limit of un is equals to limit of vn. But the question is, what is this limit? We need to get a limit. We know tn is a constant sequence. That means t0 is equals to t1 is equals to t2 is equals to t3 is equals to t4 up to is equals to tn is equals to tn plus 1 and so on. You know, from tn, t0 is equals to u0 plus 2v0 over 3 is equals to 3 plus 2 times 4 over 3. Since u0 was 3, v0 was 4 from the equation. That's equals to 11 on 3. Since tn is a constant sequence, it means tn plus 1 is equals to t0. That is, lim tn plus 1 as n turns to infinity is equals to lim t0 as n turns to infinity. That is, lim tn plus 1 as n turns to infinity is equals to 11 over 3. But lim tn plus 1 as n turns to infinity is equals to lim of 1/3 into un plus 2vn as n turns to infinity, which is equals to 11 on 3. That means lim of 1/3 into un plus 2vn as n turns to infinity is equals to 11 on 3. That means 1/3 into lim un as n turns to infinity plus 2 lim vn as n turns to infinity is equals to 11 on 3. That means 1/3 into u plus 2v is equals to 11 over 3. Since we said lim un was u in the beginning and lim vn was v, but we verified that u was equals to v. That means 1/3 into u plus 2u is equals to 11 on 3. U plus 2u is 3u. That means 3u over 3 is equals to 11 on 3, meaning u is equals to 11 on 3. U is equals to 11 on 3 means lim un as n turns to infinity is equals to 11 on 3, which is equals to lim vn as n turns to infinity. That means lim un is equals to 11 on 3 and lim vn is equals to 11 on 3.